Haley begins solving this problem by combining like terms. 3x plus 5x equals 10. So think about it. If you were to solve this problem, the first thing you would do is combine those like terms and get an 8x, correct? They wanted to know which problem down here would begin the same way. Well, on A, what would you do? You would divide by 5. B, what would you do? You could distribute out the 2 and then go from there. On C, what would you do? Right. And D, you would combine these like terms, right, and get 2x. So that was the other choice that would begin the same way. Okay, now we're going to, for the first half of class, we are going to, no, we're not going to relax. We are going to work on page 32. Okay, so turn to page 32. It looks like this. Number 1, multiplying any number by 0 yields 0. That means when you multiply a number by 0, you're going to get 0 for your answer. For example, A times 0 equals 0. What property is that? That's not identity, because remember, with the identity properties, you get back what you started with. Identity properties would be like A times 1 equals A, or A plus 0 equals A. This is the multiplication property of 0. It says if you multiply a number by 0, you will get 0. Is there an addition property of 0? No. Okay, let me say this again. The multiplication property of 0 says that when you multiply a number by 0, you're going to get 0. So tell me why we couldn't have an addition property of 0. Max? Right, you'll get back what you started with, right? All right, number 2. What property is illustrated by this statement? If A equals B and B equals C, then A equals C. Transitive property of equality. Shh, there's too much talking. Number 3, the equal sign is like a mirror, and the image it reflects is the same as the original. If A equals A, anything is congruent to itself. Reflexive property of equality. All right. Shh. Number 4. When two numbers are added, the sum is the same regardless of the order of the add-ins. The add-ins are the numbers that are added. For example, A plus B equals B plus A. Right. Commutative property of addition. All right, number 5. The sum of two numbers times a third number is equal to the sum of each add-in times the third number. For example, A times B plus C equals A times B plus A times C. Distributive property. Okay, number 6. The product of any number and 1 is that number. For example, A times 1 equals A. A times 1 equals A is what property? Identity property of multiplication. Stop talking. Number 7. The additive inverse of a number, A, is negative A. So that A plus negative A equals 0. Right, they gave you this one. Additive inverse of a number. Yes? Yes. Additive inverse of a number. Okay, number 8. I really don't even know why this one's on here. The equal sign in an equation is like a scale. Both sides, left and right, must be the same in order for the scale to stay in balance and the equation to be true. That's just the property of equality. Okay, that is the reason we do all of this, to keep the equation balanced. Number 9, when 3 or more numbers are multiplied, the product is the same regardless of the order of the multiplicants. Those are the numbers being multiplied. For example, A times B times C equals A times B times C, but the grouping is different. A and B are grouped, and then B and C are grouped. Right. Associative property of multiplication. Right. Yeah, it would look identical except they would be adding the things. Right. More than likely it's commutative. All right, number 10. When two numbers are multiplied together, the product is the same regardless of the order of the multiplicants. For example, A times B equals B times A. Right, commutative property of multiplication. There's not a commutative property for subtraction because subtraction order matters. Like you can't do 5 minus 2 and then do 2 minus 5. They're not the same thing. One is 3, one is negative 3. Commutative property only applies to addition and multiplication, and for that same reason, associative only applies to multiplication and addition. Like both of those only apply to multiplication and addition because order doesn't matter when you're multiplying and adding. The main difference between these two is with associative, the grouping is different. Like they're the same order, ABC, ABC, they're just grouping them differently. With commutative, they're reversing the order. All right, number 11, the sum of any number and 0 is the original number. For example, A plus 0 equals A. Identity, property of addition. And this was also another one. Does anybody remember the other one? Addition, property of 0. See up here how there was a multiplication property of 0? This is also the addition property of 0. What? Yes. Okay, number 12. If you add the same number to both sides of an equation, the equation is still true. For example, if A equals B, then A plus C equals B plus C. Right, that's your property of equality for addition because you're adding the same thing to both sides. Number 13, if you multiply the same number to both sides of an equation, the equation is still true. For example, if A equals B, then A times C equals B times C. Number 14, if you divide the same number to both sides, the equation is still true. For example, if A equals B, A divided by C equals B divided by C. Right? And then if you subtract the same number from both sides of an equation, the equation is still true. For example, if A equals B, then A minus C equals B minus C. Property of equality for subtraction, right? Okay, now what I want you to do is I want you to turn to page 33, and I'm only going to give you about 3 minutes. I want you to try page 33 by yourself. It's just 10 multiple choice questions. Okay, guys, here we go. Page 33, you should have got number 1, C. Number 2, B. I'll take questions after I've given them. C, B, number 3 is D, number 4 is A, number 5 is C, number 6 is D, number 7 is D, number 8 is C, 9 is also C, and 10 is also C. Are there any that you would like me to go over that you got wrong and you don't understand? Are you joking? Which of the following does not show the commutative property? So this is commutative property of addition, that's commutative property of addition, and that is. This is multiplication. That's commutative property but of multiplication. Maybe in middle school. I don't know that it always is anymore. All right, what other questions do you have? Shh. What other questions do you have, guys? Max, number 3. Which equation shows the multiplicative inverse of a number? Okay, remember inverses, when you do inverse operations, what's your goal? Right, to cancel it out, right? So, isn't this the inverse? Oh, but that's not multiplication, so that's gone. This is multiplication, and it becomes a 1, which you would be able to cancel out, right? So it's D. Okay, any other questions? Transitive is A equals B, B equals C, so A equals C. Let me write down an actual example. It says something like if, be quiet, be quiet. It says something like if 8 plus 2 equals 10 and 10 equals 5 times 2, since they both are equal to 10, then they must also equal each other. That's what the transitive property says, that if two different things equal the same thing, then those two different things equal each other. Okay, any other questions? None? Okay, I have a question for you. Turn around. Number 1, what property is being shown in each of the following? Okay, we have 3x equals 21, and then in the next step, they're dividing both sides by 3. What property is that? POE, property of equality for division. Okay, second box, x plus 7 equals 11, and then in the second step, what are they doing on both sides? So what property is that? Property of equality for subtraction. Okay, the third box, what's going on? Right, they've distributed, so distributive property. Okay, and then this one. Remember, with reflexive property, both sides are identical. It would have to be 22 equals 22. What happened here? Symmetric property of equality. Symmetric property of equality is when they just take what's on each side and flip-flop it. All right, identify the property used in each step solving the equation. Okay, the first one is just the given equation. To get from this step to this step, think about what you would do. To get from 6x plus 6 equals 55, what would you do first? You would subtract 6. Well, isn't that what they did? Because look, on this side, there's no longer a 6. It's gone. On this side, all of a sudden, it's a 49. Doesn't that mean they subtracted by 6? So what property did they do? Property of equality for subtraction. They subtracted by the same number on both sides. Well, on this one, there's one more step. Look, divide by 7, divide by 7. So to get from this step to this step, they did the property of equality for division. Okay, so to me, the hardest thing so far was symmetric property because that's one of the newer ones. But the rest of those should be pretty easy for you. All right, number 3, find the 2 mistakes in solving the equation below. This is what I recommend. I recommend rewriting the question, working it yourself. So if you were working this, what would you do? Distribute out the 6, which would become what, Marcus? Okay. 12x minus 24 equals 12. Is that what they got? Right. She forgot to distribute the 6 to the negative 4. So there's one mistake. Then after this, what would happen? You would have to add 24 to both sides, but that's obviously going to be wrong because they didn't have the right number there to begin with. Also, yes, they should have, at least they should have added 4 to both sides, but that was the wrong number to begin with. So those are the 2 mistakes. All right, number 4. Given y equals mx plus b, solve for x. Don't let that word given throw you off. All they're saying is in y equals mx plus b, they want you to solve for x. So what do you do first if we're trying to get that x by itself? Right, subtract the b, cancel it on this side, subtract it on this side. Now, you can't actually subtract b from the y, so you just rewrite it. And now it equals mx. Now to get the x by itself, what do? Divide by m on both sides. The m's cancel. And so aren't I left with x by itself now? And doesn't it equal y minus b over m? But I choose to write it like this. X equals y minus b over m. What property tells me that I can flip-flop the sides like that? Symmetric property of equality. I prefer to write my final answer with the variable that I've solved for on the left. So if it didn't end up on the left, you can reverse it and put it over there, and that's the symmetric property of equality. Okay, given a equals 2b plus 2c, they want you to solve for b. So what do I do first? Subtract the 2c. It'll cancel on this side because those are additive inverses. And then it'll subtract on this side, and you can't actually subtract it, so you just rewrite it. A minus 2c equals 2b. Now to solve for b, what do? Divide by 2, and then divide this side by 2. However, okay, look up at the board so you don't miss anything here. I'm going to go ahead and apply the symmetric property and put the b on the left. And then when I rewrite all this on the right, I'm going to split the 2 up and put it under the a and put it under the 2. But when I put 2 over 2, it becomes 1c. So that's what the final answer would look like. They're just saying, like, given this equation, solve for b. All right, number 6. Here you have x over 3 minus 6 equals y. Solve for x. Would you like that better? Here you have x over 3 minus 6 equals y. They want you to solve this one for the x. So what do we do first? Add 6 first. You can in this case because that 6 is not up there. Had it been up there with the x, you would have had to have multiplied by the 3. But it's not, so you can go and add it to the other side. Now on the left side, I have x over 3, and on the right side, I have y plus 6. Now what do I do to solve for x? Right, this is where you got to be careful, so pay attention. When I multiply this side by 3, 3 divided by 3 cancels because you have a 3 on top and a 3 on bottom, leaving x by itself. When you go over here to multiply this side by 3, you're multiplying the entire thing by 3. So represent that with parentheses and then distribute it out, making the final answer what? 3y plus 18. Go ahead and multiply everything over there by the 3. So when you multiply the y by the 3, you get 3y. When you multiply the 6 by the 3, you get 18. Does that make sense? No. Number 7. X minus 8 plus 2x over 2 is greater than 7. Yes, the first thing we should go ahead and do is combine like terms. This x and this 2x will become a 3x. So it'll become 3x minus 8 over 2 is greater than 7. Now what do we do? Multiply both sides by 2. 2 over 2 is 1, so it just leaves 3x minus 8 is greater than, and now what do we do? Add the 8, additive inverses, and now you have 3x is greater than 22, right? 22. And then you use the division property of equality, and you end up with x is greater than a decimal. It's going to be 7 point something. Okay, so x is greater than 7.33. Okay, we're going to do one more. One more. Yes. Number 8. No, you don't have to do it. Tomorrow we'll go over the rest in class. Number 8, solve the inequality and graph the solution. To solve this inequality, what would you do first? Divide by -3. So those cancel, leaving x by itself, and the number becomes -7. What else do you have to do? Right, we divided by a negative sign, or negative number, so you take this greater than sign and make it less than. Now we're going to plot it on the number line. So whenever no numbers have been given, I normally just put 0 in the middle, and then I put the number that I'm going to be circling, and then its opposite on the other side. When no numbers have been given, that's normally how I number it. Okay, so x is less than -7 means we circle the -7. Is it opened or closed circle? Open, because the answers are not equal to -7. They just start at -7, and then they're what the -7? Less, which would be which way? Left. Numbers like -8, -9, and so on. Okay, now let's write this in interval notation. Your solutions go how far to the left and how far to the right? -7, parenthesis, and parenthesis, because no, this is not on this test, this part. Okay, I'm just doing that now so that when we get to that, it's a little easier for you. Okay, tomorrow we will finish up the review sheet, and your pink sheet is due. Friday we will take the test, and your grade sheet is due.